Connecting a large ground wire or grounding electrode conductor, abbreviated GEC, to a lug that is bolted to the panel instead of directly to the neutral grounding bar because the wire is too large to fit or the neutral grounding bar is too small is a code violation. Furthermore, using a GEC to the panel case itself is also a code violation. In scenario 1, using a large ground wire to a lug bolted to the panel is a code violation because National Electrical Code Section 250.28 requires that grounding electrode conductors be connected to the grounding electrode system without splices or connections, except where made for testing purposes. Connecting the GEC to a lug creates a potential for loose connections or corrosion, which could compromise the integrity of the grounding system. In scenario 2, using a GEC to the panel case is a code violation because National Electrical Code Section 250.112 requires that equipment grounding conductors, abbreviated EGC, be connected to the equipment grounding terminal bar within the panel. Using the panel case as the EGC path bypasses the grounding terminal bar, which is designed to distribute the fault current throughout the panel enclosure. This could lead to electrical shock or equipment damage in the event of a fault. Both the GEC and EGC should be connected directly to the appropriate terminal bars within the panel. If the terminal bars are too small to accommodate the wire size, larger terminal bars or a separate grounding bus should be installed. The grounding electrode conductor, or GEC, is a crucial component of an electrical system, serving as the primary pathway for fault current to return to the source, typically the utility transformer. This connection ensures the proper operation of overcurrent protective devices, such as circuit breakers or fuses, during a fault condition. The GEC connects the electrical system's grounded conductor, often the neutral, to a grounding electrode, such as a ground rod, metallic water pipe, or concrete encased electrode. The size of the GEC is determined by National Electrical Code Table 250.66, which is based on the size of the service entrance conductors. A properly sized GEC provides a low impedance path for fault current, facilitating rapid clearing of faults and minimizing the risk of electrical shock or fire. The equipment grounding conductor, or EG, provides a low impedance path for fault current from the non-current carrying metal parts of electrical equipment back to the source. This includes equipment enclosures, metal conduit, and other conductive components that could become energized during a fault. The EGC ensures that fault current can flow safely back to the source, tripping the overcurrent protective device and energizing the faulty equipment. The size of the EGC is determined by National Electrical Code Section 250.122, which is based on the rating of the overcurrent protective device protecting the circuit. A properly sized EGC provides a low impedance path for fault current, preventing dangerous voltage buildup on equipment enclosures and reducing the risk of electrical shock. National Electrical Code Section 250.28 outlines the requirements for connecting grounding electrode conductors to the grounding electrode system. This section emphasizes the importance of making connections without splices or joints, except where specifically permitted for testing purposes. The intent of this requirement is to ensure the integrity and reliability of the grounding system by minimizing the potential for loose connections, corrosion, or other factors that could compromise its effectiveness. Permitted methods for connecting GEC to grounding electrodes include exothermic welding, listed connectors, and other approved means that provide a permanent and reliable connection. National Electrical Code Section 250.112 specifies the requirements for connecting equipment grounding conductors to the equipment grounding terminal bar within the panel. This section mandates that EGC be securely connected to the grounding terminal bar, which serves as the central point for distributing fault current throughout the panel enclosure. The grounding terminal bar is typically bonded to the metal enclosure of the panel, providing a continuous grounding path for all connected equipment. By connecting EGC directly to the grounding terminal bar, fault current is effectively distributed throughout the panel enclosure, minimizing the potential for voltage buildup and reducing the risk of electrical shock. When the terminal bars within an electrical panel are too small to accommodate the required size of grounding electrode conductors or equipment grounding conductors, it becomes necessary to install larger terminal bars or a separate grounding bus. This ensures that all grounding conductors can be properly terminated and that the grounding system maintains its integrity. Larger terminal bars provide more space for connecting multiple grounding conductors, while a separate grounding bus offers a dedicated point for terminating grounding conductors, especially in panels with limited space. Both options must be properly sized and installed in accordance with the National Electrical Code to ensure a safe and effective grounding system. When connecting grounding electrode conductors and equipment grounding conductors, it is crucial to avoid creating loose connections or conditions that could lead to corrosion. Loose connections increase the impedance of the grounding path, hindering the flow of fault current and increasing the risk of electrical shock or equipment damage. Corrosion can also compromise the integrity of the grounding system by reducing the conductivity of connections and creating potential points of failure. To prevent these issues, use listed connectors and ensure that all connections are properly tightened and protected from moisture and other corrosive elements. Regular inspections and maintenance can also help identify and address any potential problems before they become serious.